So let's see the preparations of the phenols. Phenols can be prepared through several ways. It can be from aloerins. It can be prepared from benzene via benzene sulfonic acid. We'll see how do we do that. And we can also prepare from aniline by using the diazonium salts. And we can also prepare from cumene. So we'll see what are these different ways from which the phenols are prepared. So Dow's process. I said the preparations of the phenols from the aloerins. So this is the Dow's process. We are using the aloerins. So what are aloerins? It's an arene group that is attached to the halosine. So the Dow's process is preparing the phenols by using this aloerin. This is an industrial method. So in this, we are using the haloarines and we are preparing the phenols. So you can see here, there is a chlorobenzene. So what is this? There is a benzene ring attached to the chlorine. Okay. So this chlorobenzene is converted into the sodium phenoxide in the presence of NaOH at 623 Kelvin, 300 atmospheric pressure. So chlorobenzene reacts with this sodium hydroxide in order to form the sodium phenoxide. Remember, this is a sodium and benzene with O. So we call it as sodium phenoxide. And remember, the conversion from the chlorobenzene to sodium phenoxide will be taking place at I degrees, okay, I temperature at 623 kelvins. So if you convert this into degrees Celsius, it would be around like minus 623 minus 273. You will be getting in Celsius and at 300 atmospheric pressure. So this reaction, in order to convert the chlorobenzene into sodium phenoxide, this will happen at high temperature and high atmospheric pressure. Okay. So remember, here the reagents and the reaction condition should be the chlorobenzene should react with the sodium hydroxide, 623 kelvins and 300 atmospheric pressure. So you will be getting the sodium phenoxide. Now this sodium phenoxide is reacting with the hydrochloric acid and it will be converted into the phenol. Okay, so you are treating whatever this sodium phenoxide that you got in the previous step, you are treating with the hydrochloric acid. So when you treat with the hydrochloric acid, it will finally produce the phenol. Understood? So the chlorobenzene, you are reacting it with the sodium hydroxide at 623 Kelvin, 300 atmospheric pressure. So high temperature and high pressure. So finally, you are getting the sodium phenoxide. And this sodium phenoxide, you treat with an acid, hydrochloric acid. Finally, you will get the phenol. Understood? So this is a two-step process. In order to get the phenol from aloerins, you need to go with a two-step process. So one is chlorobenzene to sodium phenoxide. The other is sodium phenoxide to phenol. Or else they can also give like this. So C6H5Cl. When you treat with NaOH, so this will give C6H5ONa. And you will be getting the hydrochloric acid. Now this one you treat C6H5ONa, you treat with hydrochloric acid, you will be finally getting into C6H5OH plus NaCl. So here you will be getting HCl, here you will be getting NaCl. So this is the two-step process. Understood? So what is Dow's process? It is the industrial method to produce the phenols from chlorobenzene. And it is a two-step process. The chlorobenzene reacts with the sodium hydroxide at 623 Kelvin at 300 atmospheric pressure. It will be giving the sodium phenoxide. Now this sodium phenoxide, you are treating with hydrochloric acid. It will further give into the phenol. Okay. So the first step is conversion of the chlorobenzene to sodium phenoxide. The second step is conversion from sodium phenoxide to the phenol. And what are the reagents and the reaction conditions? It's very important. You need to, first step will involve the sodium hydroxide. The second step will involve the acidic condition, hydrochloric acid. And the first step requires high temperature, high pressure. Is this clear? Any doubts?
No, sir.
Okay.
Sir,
Yeah.
NaCl, NaCl will be formed, right? But it's not given in the diagram.
Our main compound is this. These are all the substrates that we get. Okay. Yeah. So the next one is the phenol from benzene via benzenosulfonic acid. That means benzenosulfonic acid is the intermediate that is formed. So first we need to convert the benzene into benzenosulfonic acid, and from benzenosulfonic acid, you will be getting the phenol. So this is a two-step process. Understood? So first we are forming the benzenosulfonic acid. From benzenosulfonic acid, we are converting into the phenol. Okay. So you can see here, first you are taking the benzene. Benzene is treated with the oleum. So oleum is nothing but H2S2O7. And you are getting this benzene with SO3H. So what do we call it as? So this is called as the benzenosulfonic acid. Now this one you are treating with the NaOH. So when you are treating with the NaOH, you are finally getting this one. What is this? Sodium phenoxide. This sodium phenoxide you are finally treating with the hydrochloric acid, where you are doing the acidification and you will be getting the phenol. Okay. So actually it's the main steps are two, but there are so many intermediate steps are there. Okay. So you can see here, first what we are doing, the formation of this benzenosulfonic acid. So how we are doing, we are taking the benzene, and this benzene, which is C6H6, you are treating with H2S2O7. So H2S2O7 is nothing but a oleum. Now this oleum, when you treated with this benzene, you got the benzenosulfonic acid. Now this benzenosulfonic acid has to convert into the sodium benzenosulfonate by treating with the sodium hydroxide. Okay. Once you got this sodium hydroxide, now again you treat with the sodium hydroxide, and finally you will be getting the sodium phenoxide. So sodium, and there is a phenoxide. Okay, sodium phenoxide. And you will be getting finally the phenol. So what is this called? What is the name of this? Benzene.
Benzene.
And what is the name of this? Benzene with
Sulfonic acid.
SO3H. So what we call this as? Benzene sulfonic acid. Now this benzene sulfonic acid, you are treating with NaOH, and you will be getting the sodium benzenosulfonate. So this is sodium benzeno. Okay. Now this sodium benzenosulfonate is treated with the sodium, and here the fusion with the sodium hydroxide is happening here. Okay. So you will be finally getting this sodium phenoxide. Now this sodium phenoxide, you are doing this acidification and you are getting the phenol. Okay. So tell me, what is this step called? The step involved here, the conversion of the benzene to benzenosulfonic acid. Okay. So this step, the benzene is treated with the oleum, and this oleum, how do we, what is this oleum? It is H2S2O7, right? So how do we form this oleum? This oleum could be made with a sulfuric acid that is treated with the sulfur trioxide. So H2SO4, which is sulfuric acid. You treat this sulfuric acid with the sulfur trioxide, or you can say SO3, which is sulfur trioxide. So finally, you will be getting the S2O7. You can see here, there are two S, so S2. O4 plus O3, O7. So the mixture of the sulfuric acid and sulfur trioxide will form the oleum. Remember, okay? So this is sulfuric acid, and this is sulfur trioxide. So you mix both the sulfur trioxide and sulfuric acid, you will be getting this oleum. Now you treat this benzene with the oleum, and you will be getting this benzenosulfonic acid. So that's the step one. So what is the step one? So benzene is treated with the oleum, and it will produce the benzenosulfonic acid. So now this benzenosulfonic acid is treated with the sodium hydroxide. So this is the second step. So when it is treated with the sodium hydroxide, it will convert into the sodium benzenosulfonate. Okay. So what is the structure here? This is C6H5SO3Na. And what about this? This is C6H6, sorry, H5SO3H. This is C6H6. See, I'm also giving this because sometimes in the question paper, they will not give the structure. They can give directly this one. So by this formula, you should be able to understand this is sodium benzenosulfonate. Okay. So don't just simply go with the structure. You should also remember the formula. Now, this sodium benzenosulfonate, it will fuse with the sodium hydroxide. Okay. So whatever the excess sodium hydroxide is there, remember here we use the excess NaOH. Okay. At high temperature, so that will be converted into the sodium phenoxide. The sodium phenoxide is C6H5ONa. Now, finally, you are doing the acidification. This is the final step. So acidification that you are doing by the hydrochloric acid. So you are getting the phenol. Understood? So how we are doing the phenol from benzene to via benzenosulfonic acid and finally getting the phenol. Is this clear for everyone? Any doubts?
No, sir.
No, sir.
What about Mandara? Sleeping?
No, sir, I was not able to unmute.
Okay. Nitya, you understood this?
Yes, sir.
Okay, okay, fine. So let's move forward. So now we are doing the phenols from aniline. Here we are doing with via diazonium salt. Okay, so the preparations of the phenol by using the aniline and passing through this diazonium salt. Okay, so how we are doing here, it is also two-step process. First, we are forming the benzene diazonium salt, and from this benzene diazonium salt, we are getting the phenol. Okay, so converting the benzene diazonium salt to the phenol is the second step. The first step is the formation of this benzene diazonium salt from aniline. So you can see here, the reagents that we will be using in this step is NaNO2 HCl. What is NaNO2? Sodium nitrate.
Diazonium salt.
Yeah, but the name is actually sodium nitrate. Okay, remember. And here it is not a very high temperature you don't need. You need a very low temperature. And remember, the low temperature is very, very crucial for this step. Okay, so because the low temperature will prevent the decomposition of this unstable diazonium salt that we are using here. Okay, so if you use high temperature, that can decompose this sodium nitrate. So in order to prevent that, you are using the low temperature to prevent the decomposition of this unstable diazonium salt. Remember, okay, so low temperature is used to prevent decomposition of unstable diazonium salt. Okay. But whatever the second step is there, you will be using the warm temperature. Okay. So you are taking the steam, hot water, or warm water. So let's see how does this will happen. So see here, first one is the formation of the benzene diazonium salt. So you take this. So what is this? This is a aniline. Okay. So remember C6H5NH2, it is called as the aniline. C6H5NH2. This is called as aniline. Now this aniline is treated with NaNO2, which is a sodium nitrate. Did I use nitrate or nitrate? Guys, sorry, it's my mistake. It's not nitrate, it is nitrite. Okay. So this is a sodium nitrite. This sodium nitrite is also called as the diazonium salt. So upon treating this aniline with the sodium nitrate at very less temperature, in presence of this hydrochloric acid, it will be converted into this. So what is this called? The benzene with a diazonium salt. So this is called as the benzene diazonium salt. Remember, so this is called as benzene diazonium salt. This formula will be C6H5 and N2Cl. Always remember the benzene will be C6H5 and whatever it's here, that you will be writing here, N2Cl. Okay. Now you are treating with the warm water, so it will give the phenol, that is C6H5OH. So when you treat with the warm water, it will give the phenol. This is a phenol. So what we are doing here? So whatever the diazonium salt, the benzene diazonium salt is there, it is hydrolyzed. That means whenever you treat something with the water, we call it as hydrolyzed. That means water is added. So hydrolyzed to form this phenol. Understood? So how we are doing? First, we are taking the aniline. So aniline is C6H5NH2. That's nothing but the benzene ring with NH2 group. So you are treating with the NaNO2, which is a sodium nitrite, or you can also call this as the diazonium salt at low degrees temperature in presence of HCl. This is giving the benzene diazonium salt. So this is the step one. So the step one is formation of this benzene diazonium salt. So once the benzene diazonium salt is formed, now you are doing the hydrolyzation. So finally getting the phenol. Okay. So apart from the phenol, whatever this N2 is there, it will be liberated like a nitrogen gas as well. So you will be getting C6H5OH plus HCl plus N2. Okay. So this will be C6H5 plus NH2 plus NaNO2 plus 2HCl. So the reaction will go like this. C6H5 NH2 plus NaNO2 plus 2HCl. So this will be giving C6H5N2Cl plus NaCl plus 2H2O. Now this is further you are treating with a water. So you are doing here hydrolyzation and you are obtaining the phenol. Understood? So this is the step one and this is the step two. So what is the step one is called as the formation of this benzene diazonium salt. Step two is called as converting the diazonium salt into the phenol. Okay. And remember, whatever the step one is there, it is called as the diazotization. Why? Because you are treating with the diazonium salt and you are adding this diazonium to the benzene ring. So this step is also called as diazotization. Remember this name. So this is called as diazotization. From cumin. So preparations of phenol from the cumin. So we'll be using the cumin and we are getting the phenol. So it will be happened by 3 steps. So let's see each of the step. So the first step. So the step one is the formation of the cumin. So tell me what is cumin? C6H6 plus CS3CH. Double bond CS2. It gives C6H5 CHCS3 twice. C6H6 is called?
Benzene.
It's a benzene. Sharon, tell me what is this? Okay. So when you treat the benzene with a propylene, it will give the benzene with a propylene. So that we call it as isopropyl benzene. So isopropyl benzene. So this isopropyl benzene is called as cumin. Remember. So this is also called as cumin. So that's the step number one, formation of the cumin from benzene. So you take a C6H6, you treat with a propylene. There is a 3 carbons with a double bond. And this will attach to the benzene ring. That will turn out to be isopropyl benzene, which is called as cumin. Step number 2. Oxidation of this cumin. How do we do this? Again, you take C6H5 CHCS3 twice. Isopropyl benzene. So oxidation means we need to treat with the oxygen. And this will happen at a high temperature, that is 95 to 135 degrees Celsius. And this will turn out to be C6H5 CS3 thrice. Actually, it is not thrice, it's a twice. OOH. Okay. So what it could be called as? OOH. If something is OOH, that means the bond is like this. What we call this kind of bond? Peroxide. Remember, this type of bond, we call it as peroxide. So this is cumene hydroperoxide. Remember the name. So this is oxidation, and this name is called cumene hydroperoxide. Now this cumene hydroperoxidase will involve in the step 3. So what happens in the step 3 is acid catalyzation. So actually there will be rearrangement will happen with the help of an acid that will catalyze this process. So this is called as acid catalyzation process. So what happens here is, so whatever this cumene hydroperoxide is there, so in presence of the acid, so what does the acid will do? Acid is a proton donor. Yes or no? So in presence of that proton, which is donated by an acid, so this will convert into C6H5OH and CS3COCS3. So now, what is this called? What is this? C6H5OH. It's nothing but a benzene with OH. So we call it as phenol. Okay. So remember, this is a benzene C6H5 and it is having OH. So this is called as phenol. And what is this called? Acetone. It is a ketone. CS3, C double bond O, CS3. So this is a ketone. Actually, there are how many carbons are there here? 3 carbons are there. So it's called as acetone. Remember, so this will happen in a 3-step process. Step 1, the formation of the cumene. How do you form the cumene? You will be taking the benzene, react with the propylene, that will form the isopropyl benzene, which is nothing but a cumene. Step 2, you will be oxidizing whatever the cumene you got in the previous step. So oxidation means you are reacting with the oxygen at 95 to 135 degrees Celsius. Then you will be getting cumene hydroperoxide because it is a OOH. So if there is a single bond O with the other O and that is attached to hydrogen, so such kind of bond, we call it as peroxide bond. So cumene hydroperoxide. Now this cumene hydroperoxide is treated with an acid catalyzation and that will undergo rearrangement and it will split into 2 different kinds of molecules. One will be the phenol, the other one will be the acetone. Okay, in presence of this proton. So these are the 3 steps involved. Understood?
Yes, sir.
So see here.
Yes,
So cumene, you can see here. Actually here, the preparation, I'm starting directly from this, from cumene to the phenol. So this step is not included. So you can see here. So cumene plus oxygen followed by acidic hydrolysis. So you can see here, this is called as acidic hydrolysis. That means you are breaking down into 2 compounds with the help of water molecule breaking. So that is called as hydrolysis, acidic hydrolysis. Just remember this. It can also be called as acidic hydrolysis. Okay. So the step 1 is this one, the formation of the cumene hydroperoxide with the help of cumene. So this is a cumene. The cumene is treated with the oxygen and you are getting this cumene hydroperoxide. So this step is called as formation of cumene hydroperoxide with the help of cumene. And then second step where you are treating with an acid. This step is called as acid catalyzed rearrangement, or you can also call it as acidic hydrolysis. Okay. So see here, cumene plus oxygen followed by the acidic hydrolysis. It is nothing but it gives the phenol and acetone at the end of this. So you see here, this is the, what is this? Tell me what is this? Is it a cumin or cumin hydroperoxide? Arey, just now I told you, na, C6H5CH CS3 twice. C6H5CH
You mean?
CS3 twice. You can see here C6H5CH, and there is a 2 CS3 twice are there. That's why it is a CS3 twice. Understood? So C6H5 that will donate this. CH, this one. CS3 twice, this one and this one. Understood? So this is nothing but a cumin. Now this cumin will undergo oxidation and followed by the acidic catalyzation rearrangement or treating with an acid, okay, or acidic hydrolysis. That will finally give the phenol. This is the phenol and this is the acetone. So see here, the step one is the formation of cumin hydroperoxide. So you can see here, this is the cumin. And this is cumin hydroperoxide. So this is the formation of cumin hydroperoxide, step one. And the step two is the treatment with an acid. You can see here. So this will be happening at the 50 to 90 degrees Celsius, and it will give the phenol and acetone. So this step is called as acid catalyzation or treatment with an acid. So you can call acid catalyzation rearrangement. Understood? Any doubts? So how we are treating phenols from cumin? Okay. So try this one. Does this looks like something familiar, which we talked in the first step? Does it look like something? I said there, it is a propylene. But instead of having double bond, the bond has broken and it is attached to chlorine. So moreover, it is like a propylene, but chlorine is attached instead of having double bond. So what I will get here? I just gave you a clue. At least try now. See, in this step. So you see here, this is CS3CH double bond CS2. So what has given here there CS3 double bond instead of CH2 CS2Cl. They gave this. They gave this. Instead of having double bond, they included the chlorine. So that's how it is CS3 CH2 CH2Cl. But finally, we'll be getting this only. So you can try now. Understood? CS3 CH2 CH2Cl. So question is almost the same. But here, instead of having double bond, I included the chlorine. What is this called? Tell me, what is this called? Before it is a propylene. What is this called?
Chloropropylene.
Chloropropylene? No, it's a propyl chloride. Propylene, E and A you will not use. There's no double bond now. So you will be using as propyl chloride. So remember, this is a propyl chloride. So by this, you might have understood what will be the P. So you need to find out Q and R. And you know what happens with the oxygen and acidic treatment, oxidation and acidic treatment. You will be getting Q and R. So what is the Q and R? Just now I told you, na? What is Q and R? Guys, please listen carefully. So what we got here, when you treated with an acid, you got the phenol and acetone. So what should be the answer here? Tell me, what is the answer?
Option C.
Yes. Shrikar, tell me, why couldn't you answer? I need everyone's explanation. So what's the problem? రే శ్రీకర్
Yes, sir.
మాట్లాడరా
I was just thinking, sir.
ఎంతసేపు ఆలోచిస్తావు ఈ లోపు నీట్ ఎగ్జామ్ అయిపోద్ది 3 hours.
Yes,
అరే
sir.
చెప్తున్నప్పుడు కేర్ఫుల్ గా వినరా.
Yes, sir.
వాట్ అబౌట్ యూ శరణ్?
Sir, I confused with option C or D.
సి
C or D, I'm confused again, sir. అంటే రెండు options.
ఓకే ఓకే ఐ కెన్ టేక్ ఇట్ యాస్ అ వ్యాలిడ్ పాయింట్. వాట్ అబౌట్ యూ మందరా?
Sir, I was trying and I got confused.
It is easy to say confuse. When I explained this just a previous slide, and how could you confuse? Are you guys writing anything when I am teaching? Do it. You guys write. At least don't simply listen. Write and listen. It's okay. You don't need to write everything. At least whatever you could able to write in that point, just write it. But don't simply sit and listen what I am teaching. This is chemistry. You need to write it. You need to put on the book. Otherwise, it will not go into the brain. Come on. So when I'm writing, you also write. So see, what happened here? There is a benzene that is treated with the propyl chloride. So you take the benzene and you treat with the propyl chloride, CS3, CS2, CS2, Cl. So when you are treating in presence of anhydrous aluminum chloride, you will be getting, what will get here? What is that? Compound name. Wow.
Isopropyl benzene, you mean?
Yeah, cumin. So it's a benzene with a CH, CS3, CS3. So this is called as isopropyl benzene. Or you can also call it as cumin. Now this isopropyl benzene, what we have done? Treated with the oxygen. Then we'll get Q and R. So treated with the oxygen and then you treated with an acid, their rearrangement will happen and produce the Q and R. So when it is treated with the oxygen, so what happens when it is treated with the oxygen? What is the compound that we got here? I told you there is a OOH bond that has some special name called peroxide. So what is that called? Cumin hydroperoxide. Just understand the naming. So if any oxygens are attached with a single bond that is attached to the other compound, it acts like a bridge. So that bridge is formed by two oxygens having single bonds. So we call it as peroxide. And it is attached to the cumin. So it is called as cumin hydroperoxide. See, if you don't remember this way, chemistry, how much you mug up, you will not understand anything. You will not recall anything. So at least add a minimum concept here, minimum logic here. So it will form when you treat it with oxygen at 95 to 135 degrees Celsius. It will form the benzene ring attached with carbon CS3, CS3, OOH. So there is a OOH. So we call this as the cumin hydroperoxide. So this step we call it as oxidation. Now this will undergo rearrangement in the presence of acid. So H3O plus, or you can also put it as H plus at 50 to 90 degrees Celsius. So that will be giving, one will be the phenol, the other will be acetone. So CH3 carbon double bond O CH3. It is nothing but RC double bond OR. So this is nothing but a ketone, RCR double bond O, which is nothing but a ketone. And this is an alcohol. So this is an acetone and this is a phenol. Okay, so these are the answers. One will be the P. The P is nothing but this one. You can take this as a P and you can take Q and R. This will be the Q and this will be the R. Understood? Any doubts here?
No.
Okay, so remember, in this one thing you need to remember. So whatever this first step is there, so it is called as the Friedel-Crafts alkylation. Okay, so whatever that you are treating the benzene ring with a propyl chloride and catalyzed with the help of aluminum chloride. So this step we call it as the Friedel-Crafts alkylation. Named reactions are very important. So this is a Friedel-Crafts alkylation. So at the end of the Friedel-Crafts alkylation, you will be getting the isopropyl benzene, which is nothing but a cumene. Okay, so remember, this is also called as the Friedel-Crafts alkylation. So why we call it as alkylation? So you can see for the benzene ring, I am attaching the alkyl group. Yes or no? So what is this? This is a propyl. That means propane, which is nothing but C6, sorry, C3H3 to 2n plus 2, right? 2n, that's a 3 to 6. Yeah, 3 C3H7. So this is, wait, plus 2. So 3 to 6 plus 2, 8. So actually this is a propane. For this propane, I am removing one hydrogen. This becomes a propyl. So I am attaching an alkyl group. So that's why it is called as alkylation. And it is Friedel-Crafts alkylation. Understood? So why we call this as an alkylation?
Yes, sir.
So remember the benzene ring with a propyl chloride in presence of anhydrous aluminum chloride, it is giving isopropyl benzene, which is also called as cumene. So that reaction, we call it as a named reaction, which is Friedel-Crafts alkylation. Remember, the Friedel-Crafts alkylation is very, very important named reaction. So this is very, very important. Okay, so now this isopropyl benzene, you are doing the oxidation at 95 to 135 degrees Celsius. So you are getting the cumene hydroperoxide. Okay, so that's the reaction with the oxygen. So giving cumene hydroperoxide. And then you are reacting with H3O plus, or you can say the H plus as well. That means an acid. So nothing but you are reacting with an acid. You are getting the phenol and acetone. Okay, so this product of this reaction is the phenol and acetone. So here I can use that CH3, CH2, CH2Cl, or I can also use CH3, CH2, CH double bond CH, which is nothing but propylene. So I can use either the propyl chloride or I can use the propylene. So both can be used here. And the final product will be acetone and phenol. Is it clear for everyone?
Yeah.
Okay. So now tell me this. The same reaction, tell me this. What is missing here?
So this is option B.
Option?
B.
Option B. What about others? Is it option B only?
Yes.
అరే యార్ రే శ్రీకాంత్ నీకు అర్థం కాలేదురా
No, sir, I understood.
మరి ఏరా ఆన్సర్ చెప్పట్లేదు
No, I just thinking if it's option B or D. Sir, I was thinking, sir.
అరే
It's
ఇక్కడ సరిగ్గా చూడరా, సికి డైరెక్ట్ గా ఓఓహెచ్ అటాచ్ అయింది. సో ద ఓఓహెచ్ is directly attached to carbon, not CH3. So the answer is B. And what is the name of this? Nitya, you don't tell. Mandara, you tell. What is the name of this?
So, cumin hydroperoxide.
Super, Mandara. Super. I'm satisfied. So this is called as cumin hydroperoxide. Okay. Sharon, what are these called? Sharon,
Yes, sir.
what are these called? What is benzene with OH?
Phenol.
And what is this called? CH3C double bond O CH3. It is a ketone, but there are 3 carbons, so we call it as acetone. Remember, okay, this is called as acetone and this is called as phenol. And what is this called as? What is the name of that? Sharon, Array, Srikar, you tell me what is the name of that?
cumin,
Tell me this, the chemical name.
isopropyl benzene,
Benzene.
isopropyl.
Isopropyl benzene, which is also called as cumin. Okay. So this is also called as cumin hydroperoxide. Okay. So that's about the preparations of the phenols. So let's see the preparations of the ethers. So what are ethers? What are ethers? So phenol means the benzene ring with OH, we call it as phenol. Alcohol means the alkyl group with OH, we call it as alcohol. Then what is ether? At the beginning only I told you.
ROR.
It is nothing but ROR. Okay, so this is called as the ether. So the preparations of the ethers can be done in 2 ways. So one is the dehydration of the alcohols. The other one is Williamson's synthesis. Okay, so just remember how we do the dehydration of alcohol. So what is meaning of dehydration? You are removing the water. Remember, dehydrate. We say like, I'm so dehydrated. That means what? I lost so much of water through sweat. So dehydrated means loss of water or remove of water. Okay, so you can write as removal of water molecule is called as the dehydration of alcohols. Okay, so from the alcohols, I am removing the water molecule. So that process is called as the dehydration of alcohols. So by doing this, I am getting the ethers. But actually, will I get the ethers or will I get the alkenes is a question mark. Okay, so remember, so the dehydration of alcohols can form the alkenes, can form the ethers, but that depends on the temperature we use here. Okay, so remember, so the dehydration of alcohols, it can helpful for formation of the alkenes, and it can also helpful for the formation of ethers. But how does the formation of alkenes and formation of ethers will happen is it depends on the temperature we use here. Okay, so remember the alcohols can dehydrate to form the alkenes and the alcohols can dehydrate to form the ethers. But what are the concentration we use and what are the temperature we use, that depends on whether it is alkene or ether. For suppose you see here, this is a alcohol. And what is this kind of alcohol called? What is this? 2 carbons attached to OH. We call it as ethanol. Remember, This is called as ethanol. Now, this ethanol is treated with the concentrated sulfuric acid at 443 Kelvin. Then it gave the alkene. So this is an alkene. And water. So water is there. That's why it is called as the dehydration of alcohol. The same way, you are using the primary alcohol and you are getting the ether here. Okay. So remember, in this condition, so when you are using the 443 Kelvin, or you can say this as some 170 degrees Celsius, you are getting the alkene. The same way, if you are doing at 140 degrees Celsius, or you can say at 413 Kelvin, then you will be getting the ether. So which one needs less temperature to form the ether? Which one needs high temperature to form the alkene? Just remember that one. Okay. So remember, if you use 140 degrees Celsius and 413 Kelvin and primary alcohol, what is meaning of primary alcohol? The carbon, the OH group attached to the carbon is a primary carbon. Okay. So that primary alcohol will give the ethers. Just remember this thing. So dehydration to form an ether usually take at lower temperature compared to the dehydration of alkene. Remember, so the temperature should be low for alkenes compared to the ethers. Sorry, for ethers compared to alkenes. So temperature for forming the ether should be less than temperature required to form the alkene. So if the temperature is more, it will be alkene. If temperature is less, it will be ether. So here it is 413 Kelvin. Here it is 140 degrees Celsius. Sorry, here it is 443 Kelvin. Or you can say here it is 140 degrees Celsius. Here it is 170 degrees Celsius. Understood this thing? Is it clear or any doubt? Sharan, Mandara, guys, if you have any doubt, please ask me. I can repeat it. So just remember this. So choice between ether and alkene. So which I want to form. Okay. So the choice between ether and alkene formation can be controlled by temperature. Remember this. So at what temperature you are reacting, so that can form the ether or alkene. If it is a low temperature, it will form the ether. If it is high temperature, it will form the alkene. Clear? And remember, the mechanism here it involves is the SN2 mechanism. We have studied SN2 mechanism, which is nothing but the bimolecular nucleophilic substitution. Yes or no? So remember this. So the mechanism involved here is bimolecular substitution nucleophilic reaction. Okay.
So how do we know it's SN2 mechanism?
We studied the SN2 mechanism, no? So how does the SN2 will happen?
Two of the molecules are, I mean, one of the
Will
molecules comes in
determine the
attaches
rating, rate of the reaction. Yes. Just remember this, it will go to the SN2 reaction. I'm not diving into the mechanism of how SN2 reaction will happen here. Okay. So if you want to just know what is SN2, just go back and revise this SN2. But I'm not explaining SN2 here.
Okay.
Okay. Mhm. It's okay. I'll explain how does the SN2 reaction will happen. So how does this bimolecular nucleophilic reaction will happen? I'll tell you, but not in detail, but I'll tell you. Okay. And remember this dehydration of alcohol, it is the temperature dependence. Because based on the temperature, it will decide which product it has to form. Whether it has to form the alkene or ether, so it will depend on that. So one thing you need to remember, it is a temperature dependence. Second thing, so while you change the temperature, it will be favorable for one product and not for the other product. For suppose if I decrease the temperature, the reaction is favorable for formation of the ether. If I increase the temperature, the reaction will be favorable for alkenes. So that you need to remember. So it's a product controlled by the temperature. Third one, so the formation of the ether is happened by the SN2 mechanism. Okay. So remember this, the formation of ether will happen by SN2 mechanism. And one more thing, you need to, if you see here, what is this ether? It's a ROR, yes or no? So that means it requires the two molecules of ethanol, yes or no? For suppose if I want to form the alkene, I don't need a two molecules of ethanol. But forming this ether, I need two molecules of ethanol. Okay, so remember this thing, you remember. I'm erasing here. So remember this. Ether formation requires two molecules of alkene, sorry, ethanol. While alkene requires only one molecule. You guys understood what is meaning of ether requires two molecules and ethanol requires one molecule. For suppose you see here in this condition, so you are taking only one molecule of ethanol and that's giving one molecule of alkene. Whereas here you are taking two molecules of ethanol and it's giving one molecule of ether. So there is a two molecules of ROH. So that's giving one molecule of ether. Whereas here it's only just one molecule of ROH that's giving one molecule of alkene. Understood? Instead of saying one molecule, you can say one mole. Okay. Any doubt so far? Can I move next or you want me to quickly explain again?
So you can move.
Understood.
Yes.
Yes, sir.
See, I'll also explain you a very boring tone like should I say or not? Will that be okay? Come on, guys, be energetic. Are you not eating any food or what? I'm getting bored and tired listening to your tones.
So you can move next.
So preparations of the ethers. So you can observe here. So if you are taking this alcohol, so I mean, yeah. So if you are taking this ethanol and you treat with sulfuric acid at 443 kelvins, you will be getting alkene. And you do the same at lower temperature, you will be getting ether. Okay. So this is very, very important and very, very critical. So just remember this. So at high temperature, alkene, at low temperature, it's a ether. So let's see how do we do the preparation of ethers. So what is the mechanism? So this mechanism involves the formation of the ether by intermolecular dehydration of alcohols by using the SN2 mechanism. Okay, so how does this happen? First, suppose it will happen in the three steps. So step one, step two, step three. Step one is the protonation of the alcohol. Step two is the attack of nucleophile. Step three is deprotonation. Okay, so these are the three steps involved. So whatever the SN2 mechanism, if you remember, the same methods we discussed there. Okay, so one is protonation of alcohol, attack of nucleophile, and deprotonation. So let's see how does this happen. So first one is protonation of alcohol. So you can see here. So there is an alcohol. That alcohol is protonated by the acid catalyst. Okay, so see here, whatever this H is there, now this will be going and attacking this alcohol. And whatever the bond is broken, now this bond will shift to the oxygen present here. So this will be getting as O minus SO3H. So this is called as the protonation of alcohol. Just remember, alcohol is protonated by acid catalyst. And what is the acid we are using here? It's a sulfuric acid, H2SO4. So that is the thing that will happen in the protonation of alcohol. So what happens now? It will create a better leaving group. Okay, so that's nothing but you can see here there will be protonation of this, whatever this H is there, now it has attached to this. So when it is attached to this, now what is this called? Water molecule. So will this water molecule stable here? It is not stable. So this water molecule will leave this group. Understood? So what happened here? First, whatever the oxygen present here, it is attacked by the proton, which is present on the acid. So the acid catalyst, so whatever the acid is there, it is trying to remove this molecule. So for that, it is attacked by the acid. So there is this H will go and attach. Now when it is attached, now it forms the water molecule. The water molecule is very unstable here, so this will leave. So that's why it creates a better leaving group and makes the carbon more electrophile. Okay, so why it is electrophile? So when it leaves, this will turn out to be positive or negative. Tell me, guys, that will be turn out to be positive or negative. Electrophile means what? It is loving the electrons. Electrons loving, we call it as. Forgot. Electrophile, nucleophile. Just
Positive.
remember, electrophile, it is a positive charge which loves the negative charge, loves electron. See, it should be positive charge so that it will love the negative charge. Nucleophile, it is a negative one, so it loves the positive charge. It loves it loves the positive charge. Or you can say protons. Just don't confuse, just remember, if it is electrophile, electro means negative charge, so it should contain the opposite. So it will be positive. It is a nucleophile, that means it loves the positive charge, but it should be a negative. Remember like that. So electrophile means it's not negative charge, it's a positive charge, and it likes the electrons negative charge. Nucleophile means it is a loving the positive charge, that's why it is a nucleophile. Phile means love, nucleus means positive. So positive lover, negative lover. So if it is to be negative lover, then it should be positive. If it is a positive lover, then it should be negative. Just remember like that. So now tell me, it should be electrophile or nucleophile? So when this water molecule will leave, it will create the positive charge. Now tell me, it is an electrophile or nucleophile?
Electrophile.
It is an electrophile. Okay. Revise the concepts again, otherwise you will forget it. So you see here. So you see here, there is this OH that is attacked and there is a loss. So that created the positive charge over here. Okay. So the attack of the nucleophile will happen. So you understood this? So what happened here? It creates a better leaving group and makes the carbon more electrophile. Next one, the attack of the nucleophile. So there will be a second molecule of the alcohol that acts like a nucleophile. So nucleophile means it should be negatively charged. So the other one will act like a negative charge and this will be attacking this protonated alcohol. So whatever this alcohol is there, this protonated alcohol is attacked by this. So you can see here. Understood? So just remember, okay, I'll tell you in. So first one, this protonation of the alcohol. That means you are adding a proton to this alcohol. So that's why it is here. Okay. And this protonated alcohol, it is an electrophile. This is an electrophile. So being electrophile, it will love the negative charge. It is a positive charge and it will love the negative charge. Okay. And it creates a better leaving group. So creates a better leaving group. I'll tell you what is the better leaving group. So just remember, whenever this protonation is happened, it creates a better leaving group. Okay. And remember this alcohol name, you can consider it as a protonated alcohol because this is an alcohol and hydrogen is attached. If you remember in the last class, we discussed what is meaning of protonated alcohol. The alcohol containing OH, other than that, it is having extra H, we call it as protonated alcohol. So this is a protonated alcohol. So remember the protonated alcohol name is A. Okay. Now this A is attacked by the B. So this is the B and this is the A. So B is attacking the A. And what is B here? It is nothing but the second alcohol molecule. So like this alcohol molecule, there is another alcohol molecule is there. That alcohol molecule is attacking this protonated alcohol. So remember. So here you can say another alcohol attacks the protonated alcohol. Or you can say the electrophile. And remember another alcohol in the sense it is the B. The B is attacking the A. Understood? Is this clear? Tell me, guys.
Yes, sir.
And
Clear.
whatever yeah. So when it is attacked, now what happens? So water molecule, whatever it is present, that water molecule will be left over. So when this water molecule is left over, so this entire pink part is left. So you see, this entire pink part is left. Now, whatever this blue part is there, this blue part will attach to this. So you can see here. So that's why this is like half M that is added with this blue color. So that's how it is making the full M. Understood? So initially it was like this, but now this small part came and attached here. Understood? So this attachment will happen by the SN2 mechanism. And remember, there is a partial transition will happen here for the bond formation and bond leaving. That if you remember, we discussed in the SN2. So there is a transition state where the new bond is forming and the old bond is leaving or breaking. So that transition phase will be happening here. So if you see here, whatever this bond was there here, that bond will break, and here whatever this bond with this will make. Understood? So this blue will make a bond with this pink, and whatever this pink with the blue, it will break. So both will simultaneously happen. Leaving and attaching will simultaneously happen. Understood? Any doubt here? So just carefully listen. So there is an alcohol. That alcohol is treated with a sulfuric acid. Now what does this sulfuric acid will do is, it will donate the proton to the alcohol. When it is donated the proton to the alcohol, this will be converted into the protonated alcohol. So you can see here, initially it was like this. So I don't have this one. It's just only this part, only this part. But then I added this proton here. I added this proton here. So that's how it became a protonated alcohol, which is a A. Now another set of this alcohol molecule will attack this protonated alcohol. So that we call it as the attack of nucleophile, because this alcohol will act like a nucleophile and that is attacking this electrophile. So the B is attacking A. So when the B is attacking A, so whatever the water molecule part is there, that will be leaving this A. So that's why it is called as the creating the better living group. So you can see here, this whatever the red region is there, that red region will leave the blue part. So this part will be left. So that's why it is called as creating a better living group. So once that part is left, it will remove like a water molecule, and whatever this part is there, this will go and bind here. It will go and attach here. So that's how this will be formed. Understood?
Yes, sir.
And if you see this part, it is containing the extra proton here. Now we need to remove that proton. That is called as the deprotonation. Okay, because here extra H is there. That extra H, you can see here, this was attached to this. Okay, and whatever this extra hydrogen present on this carbon, that will be attaching here. So that hydrogen now we need to remove. So that's called as the deprotonation. So just remember, whatever the alcohol that is present here, it is protonated. Now we need to remove this proton. So that will turn out to be this, an ether. So you can call it as the alcohol which is protonated. Because if you see here, this is OH. OH is nothing but the alcohol group. So that hydrogen, if we remove, then it will turn out to be an alcohol. Sorry, an ether. Okay, so that's the step number 3. So remember, so oxygen, which is newly formed, so whatever this, 1 second, guys. Okay, so whatever this ether is there, okay, so this is like having the extra proton. So that extra proton we need to remove from this ether. So that happens. So proton from the ether, newly formed ether, is removed. So by removing, and that will be removed with the help of a base-like structure, which is HSO4 minus. I'm not showing here. Okay, so that will finally form the ether. This one is an ether. So any doubts? Come on, guys, tell me,
No,
any
sir.
doubts? Is it clear? So how does the preparation of ether happen? At least if just understand the mechanism, you don't need to remember everything step by step. But all you need to do, just know it, how the things are happening. Just try to understand. So it will happen in the 3 steps. One is the protonation of alcohol. That means the alcohol is having the proton, and that proton is given by the some sulfuric acid. Now this protonated alcohol is attacked by the another free alcohol present there. So once it is attacked, that will be converted into a protonated ether. So from this protonated ether, we are removing the proton that will convert into ether. That much simple. But I'm just explaining in detail. That could make you feel complicated, but just remember this much. So there is alcohol. That alcohol is attacked by an acid, and the proton is given to the alcohol. So that will convert into a protonated alcohol. Now this protonated alcohol is attacked by another alcohol, and that will convert into the protonated ether. Now this protonated ether, we are removing the proton. That will turn out to be ether. That's it. It is a 3-step process. Clear?
Yes, sir.
Yes, sir.
Okay. But there are some limitations for this dehydration method. So first one, synthesizing ethers using the secondary alcohol is unsuccessful, because if you are using the secondary alcohol, there is a more chances for alkenes to form, because the formation of the alkenes is too easy. Okay. So remember, synthesizing ethers using the secondary alcohol is very, very unsuccessful process. That is because secondary alcohol tend to form alkenes more compared to the ethers. So they can easily convert into the alkenes by the dehydration method. But instead, if you use the primary alcohol, then it can convert into an ether. So that's the first exception you need to know. Second one, synthesis of ethers with tertiary alcohol group lead to exclusively to the alkenes. See, secondary alcohol, you might have a chance to form the ether. But if you use the tertiary, there is a no possibility at all to make the ether. So you see, if you are using the tertiary, it is completely favorable for alkene. It is completely favorable for alkene compared to secondary, compared to primary. And primary is favorable for, this is favorable for ethers. This is favorable for alkenes. Secondary is also more favorable for alkenes compared to ethers. So remember, the synthesis of ethers with the tertiary alcohol groups, tertiary alkyl groups is exclusively for formation of the alkenes. So the reaction, and yeah, here whatever the reaction that happens here is, actually it is a E2. Okay, so E2 reaction will happen instead of SN2 reaction. So we know that SN2 reaction will take place so that you will get ether. But here what happens is elimination 2 reaction will happen so that it will form the alkenes. If SN2 reaction happens, then you will get the ethers. If E2 reaction happens, then you will get the alkenes. Understood? So remember, E2 favorable for the alkenes. SN2 is favorable for the ethers. So remember, this is for ethers and this is for alkenes. So in this, E2 reaction will happen instead of SN2 reaction. And third one is not useful for the preparation of unsymmetrical ethers from primary alcohol because the reaction leads to the mixture of products. So you can see here. So if you are using unsymmetrical ethers, for suppose you see here, this is R and this is R dash. That means both are not same. They are different R groups. For suppose you can take this is a ethanol and this is a propanol. So at that condition, you will be getting the mixture of products. So that's why this is also not correct process. Okay, so unsymmetrical ethers are not useful. So only the primary alcohols of symmetric you should use. Okay, so if you use the unsymmetrical ethers, the reaction will lead to the mixture of the products. Okay, so there will be mixture of some symmetrical products, some unsymmetrical products. So, and some undesirable products also you will get. So that's why this method is also not good to use. Understood? What are the limitations for dehydration for forming the ethers? Any doubts? So now tell me.
Option A. Says A.
So primary alcohol.
Yeah, it's a primary alcohol. So we know that if we are synthesizing these ethers from secondary alcohol or tertiary alcohol, it is unsuccessful. For suppose secondary, it is unsuccessful. And for tertiary, exclusively for formation of the alkenes. Okay, so the answer is only for the primary. Okay. Actually, this reaction can, okay. Yeah. So next one. You can take the example here like this. Okay, leave it. So just, okay, next one. So tell me. What is the answer here? So just know which one is primary, secondary, tertiary among those. You will find out the answer.
Option D.
Option D. For suppose you see pentane 2 all. That means, so what will be the, where does the OH is attached in this? On the second carbon. So on the second carbon, the OH is attached. So which alcohol is this? Primary, secondary, or tertiary?
Secondary.
Yeah. So it is actually like this. On the second carbon, OH is attached. So this carbon is attached to two different carbons. So probably this will be the secondary. So this is secondary alcohol. Now what about this? 2-methyl 2-butanol. That means carbon, carbon, carbon. On the second carbon itself, you are having another methyl group, CH3. So on this, you have alcohol. So this is which type of alcohol? Tertiary alcohol. So this is tertiary. And you see cyclopentanol. So what is meaning of cyclopentanol? So carbon, 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 carbon. So you take this carbon, carbon, carbon. Now this carbon is having OH, which is attached to two different carbons. So what will be the degree here? It is also a secondary. And pentane 1-ol. That means first carbon is attached with OH and that is attached to some 5 carbons. So this will be primary. So this will be the answer. Is this clear? Why the option D is correct answer and A, C, B are not?
Yes, sir.
Yes, sir.
Okay.
Yes, sir.
What about you, Sharon?
Sir, I said yes, sir.
Okay. So next one, preparations of these ethers through the Williamson synthesis. So before one, that's about the dehydration. Now it's the Williamson synthesis. So how does this happen? The Williamson synthesis, it is a versatile method. I'll tell you why we call this as a versatile method. Okay, because for preparing both the symmetric as well as unsymmetric ethers, we will be using the Williamson synthesis. Okay, so previous condition, we only get the symmetric one. If we try to unsymmetric, that is not possible. But here, you can get both the symmetric as well as unsymmetric ethers. And this also happens through a nucleophilic substitution reaction. Okay, so the mechanism can go like this. So RONA reacts with Rx will form the RO or NaX. So tell me what will be the RONA? What is RONA? Alkoxide. Okay, so remember RONA. ONA is nothing but the sodium oxide. So alkoxide. This alkoxide will act like a nucleophile. Remember. So this will be acting like a nucleophile. So remember RONA will act like a nucleophile and it is an alkoxide. And then what is RX? What is RX?
Alkyl halide.
It is a alkyl halide, which acts like a electrophile. So we know alkyl halides always acts like electrophiles. Okay, and there is a, this could be chlorine, fluorine, bromine, iodine. You can take. Mostly fluorine we don't take, either chlorine, bromine, iodine, because fluorine we know it's a small size and it's also very reactive. So most of the times we'll not consider the fluorine. So either chlorine or bromine or iodine. Okay. So when you react both of them, you will be getting an ether. And you see here, this is an unsymmetrical ether. Okay. So R dash O R. So unsymmetrical ether. Okay. So remember the alkoxide ions. So you see here, these ions reacts with the substrate via SN2 mechanism. So that means that will react with an alkyl halide and that will be giving different kinds of uh, products. It could be the primary or secondary alkyl halides and bear a good leaving group. Okay. Sorry. Whatever the substrate that you are using, the alkyl halides, either you can use the primary alkyl halide or secondary alkyl halide. But remember, we are not using the tertiary because if we use the tertiary, what happened? There will be hindrance effect. We studied what is meaning of hindrance effect. So that's why most of the times we are taking the primary or secondary. If we use the tertiary, that will cause the steric hindrance. So the substrate should not cause the steric hindrance. Understood? So what is meaning of here? So remember the substrate Rx must be unhindered. Okay. So typically we will be taking either the primary or secondary alkyl halides. And those primary and secondary alkyl halides will be acting like a good leaving groups. So mostly what are these are? They are nothing but they are halides. Okay. And whatever the nucleophile, it is an alkoxide ion. So that alkoxide ion will release the Na and that will turn out to be RO. Okay. And it is a nucleophile. That means it should contain negative charge or positive charge. Nucleophile. Nucleo, and that means positive charge.
Negative
So this will
charge.
turn in turn negative charge. Okay. So remember like that. And that will be attacking the electrophile. So you can see here. This one. What is this? Nucleophile or electrophile?
Nucleophile.
Yeah. So this is a nucleophile. And this nucleophile is attacking the electrophile. And what is a good leaving group here? The halogens. That could be chlorine, bromine, or iodine. So you can see here. So whatever the alkyl halides, it's an electrophile, and alkoxide, it's a nucleophile. So there will be bond breakers will happen between the oxygen and sodium, and this will turn out to be negative charge. So we call this as a nucleophile. And this will, after leaving this halogen, this will turn out to be positive charge. So that's why it is called as electrophile. Now this electrophile and nucleophile both are opposite charges, so they will join. And whatever this sodium positive charge and leaving group negative charge, so this will be leaving like a negative charge. So this will be leaving like a negative charge. So this negative charge and this positive charge will attract and form a bond. So that's how it will form NaCl, NaBr, and NaI. And this negative charge and this positive charge will form an ether. Understood? Any doubts? Is this clear, the mechanism? Or should I explain this again?
It's clear, sir.
Yes.
Okay. So tell me, what will be the product that could form here? So first, where does the bond breakage will happen? So the bond breakage will happen here. So after bond breakage happens, so how does this will turn out to be? Positive or negative?
Negative.
Negative.
This will be negative charge. And what about this? This will be positive charge. And what about this?
Positive.
So the bond will break here. So this will turn out to be positive, and the iodine will turn out to be
Negative.
the negative. So the now NaI will join and this will join to this O. Okay. So remember, this will attach to the oxygen and this sodium will attach to the iodine.
Okay.
So the product will be something like this. So CS3, CS2, CH, CS3, CS2O, and then this one, CS2, CS3. And you will be getting NaI. Clear? So here there will be negative charge, here there will be positive charge. Here it is positive charge, here it is negative charge. So they will join.